11.2 The Box and Whisker Plot. In this lesson, I will teach you how to draw a box and whisker plot. The box and whisker plot is just a data display that organizes data values into 4 groups, and they are the lower quartile, the upper quartile, the lower extreme, and the upper extreme. I will explain this in more detail as we move on with the lesson. We will also revisit the vocab word range, which is the difference between the greatest and least values in a data set. And then we'll also look at the interquartile range. Making a box and whisker plot. A farmer recorded the number of oranges that an orange tree produced for each of the last 9 years. The data are given below. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 years. And the number of oranges per year. Display the data using a box and whisker plot. First, you need to order the data from least to greatest to find the median, which is the middle number of the data set, the quartiles, and the extremes. Okay, let me explain what these are. First, we need to find out what's the smallest number, which is 264. And then 360. And then 380. 407. 452, 457, 458, 460, and then 572. As you can see, we have an odd number of numbers. Therefore, the middle number, we can choose 452 as our median. And now I need to calculate the lower quartile. To calculate the lower quartile, I need to look at the lower half of my data points. And I happen to have 1, 2, 3, 4 numbers in the lower half. Therefore, I cannot choose a middle number. Remember, the lower quartile is the median, the middle number of the lower half of the divided order data. So after I divided this data, I need to calculate the lower quartile by taking the sum of 360 plus 380 and then divided it by 2 to get 370. And same thing for the upper quartile. There are 4 numbers, so I need to take these 2 numbers and divide by 2. And we can also call this the average. And this would be 459. Now we are ready to plot a box and whisker plot. So I have a number line printed for you already. Later on, you'll need to draw your own. So first, I need to plot the lower extreme, which is 264. The lower extreme is the least data value. And I'm going to write the number 264. And then I'm going to plot 370, the lower quartile. So roughly estimate it. This can probably be around here. And I'm going to plot the median for 52. And then the upper quartile for 59. And then the upper extreme, the greatest data value of the 9 numbers, 572. Now I'm ready to connect my dots. So these are my whiskers, and I'm going to draw the box. And that's my box and whisker plot. Let me show you another one. Here in this data set, we have a total of 1, 2, 3, 4, 5, 6, 7, 8 numbers. So when we divide these numbers up, we're going to have to do it a little differently than the other one. So the lowest number is, the lower extreme is 1, and then we have 6, 9, 12, 13, 14, 17, and then 18. And you may have noticed that there's actually no one middle number in between. So we need to take the middle 2 numbers, add them together, divide by 2 to get the median. And now you're thinking, then how do I find the median of the lower half, or what we call the lower quartile? Now you need to draw a line down the middle. So 1, 6, 9, 12 will be considered your lower half. 13, 14, 17, 18 will be considered your upper half. They're equally distributed. So 6 plus 9, divide by 2, 7.5. Upper quartile, the median will be 14 plus 17, divide by 2, which is 31 divided by 2, which equals 15.5. Now I have a number line for you here, and I would like to use an interval of 2s. 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Okay, so I'm going to first plot my lower extreme, which is this 1. I'm going to write 1. And then I'm going to plot the lower quartile of 7.5, just around here. And then 12.5, my median. And 15.5. Let me write this more neatly. Okay, 15.5 will be my upper quartile, and then I need to graph my upper extreme, which is the largest number of this data, and it's 18. Okay, now I'm ready to draw my whiskers, and then my box. Okay, and then this box and whisker plot again shows how distributed these numbers are. Okay, and let's say if we have 10 numbers, think about how you would divide the lower half and the upper half. So if I were to use circles to represent numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So let's see. 5 here. 1, 2, 3, 4, 5. And 5. And then I will draw a line down the middle to find the average or to find the median. I'll take the average of the two numbers in the middle. And then if you look at the lower half, there's 5. Numbers. So the lower quartile would just be this number. And versus this example here where we have 8 numbers, you had to add 6 plus 9 and divide by 2 to find the lower quartile. And here, same thing for the upper half, you just take the middle number of the 5 numbers, 1, 2, 3, 4, 5. So you better understand the difference between 10 numbers and 8 numbers and how to divide these numbers equally. So how do we interpret a box and whisker plot? Okay, look, a box and whisker plot separates data into 4 sections: the 2 parts of the box and the 2 whiskers. So here we have the 2 parts of the box, and then we have 2 whiskers. All 4 sections contain approximately the same number of data values or data values. Okay, so what does that mean? So each whisker represents about 25% of the data. The entire box represents about 50% of the data. So about 25% of the data lie in the box on each side of the median. So here's 25, and this is also 25, totaling 100%. That's how you interpret a box and whisker plot. Okay, let's take a look at some sample problems on how to interpret box and whisker plots. State parks. The box and whisker plot below displays the number of visitors in millions to the state park in each of the 50 states in 2000. A. About how many states had fewer than 18.2 million visitors to their state parks? So earlier I mentioned that each whisker represents about 25% of the data. So this would be 25, and 18.2 happens to be the what? The upper quartile. So what each side of the box also represents 25%. So 25, 25, 25, this would equal to 75%. And since 75% of the states have fewer than 18.2, we can take that percentage and multiply it to 50, the total number of states, to get 37 states. Part B. West Virginia had 8 million visitors to its states. How does West Virginia compare with the rest of the states? So the number of visitors to West Virginia happens to be greater than the lower quartile, so 4.6. So this means West Virginia had more visitors than 25% of the state. states. This 25% would just represent this part of the whisker. On the other hand, since 8 is less than the median of 8.9, this means the number of visitors was fewer than 50% of the states. And again, the 50% represents this part. Okay, so this is 25%. This part of the box is 25%, 25, 25, 50. And that's how we read or interpret a box and whisker plot. Okay, let's take a look at one more example. Weather. The box and whisker plots below show the average monthly temperatures for Boston and Seattle. What conclusions can you make? So here we have Boston, Seattle. Okay, so in this case, we need to think about the mean. Actually, the median. This must be a typo. So let me go ahead and erase that. The median, range, and interquartile range. And if we look at the median, you can see that 51.5 and 52, they're about the same. So you can conclude nearly identical. Temperatures. And now I would like to compare the range and interquartile ranges. Okay, so 2. Range. Interquartile range. I will tell you what interquartile range is in a bit. I haven't defined it yet for you. Okay, so Boston. I'm just trying to make a little chart. Seattle. So the range for Boston will be 74 minus 29, and that would be 45. And for Seattle, it's 66 minus 41. This is 25. And for the interquartile range, you take the upper quartile of 66.5 and you subtract it from the lower quartile. So by definition, the interquartile range is basically the difference between the upper quartile and the lower quartile. So 66 minus, I apologize, 61, the upper quartile of 61 minus 45 for Seattle, and after doing the math, you should get 30 for Boston and 16 for Seattle. And what can we conclude? The range is greater for Boston, and so is the interquartile range. And therefore we can say Boston's temperature is more spread out. Than Seattle's. Because the range and both the range and the interquartile range are bigger. Okay, and that concludes our lesson for Box and Whiskers.